Okay, so we're going to talk about chapter 4 a little bit today, finish it up and then move on to 5. But one of the things you can do to help yourself with trig is what a lot of nursing students do. And that is they make up 3x5 cards and they'll quiz themselves, see if they know the formulas. You know, if I'm given a name, what are the formulas? What are all the formulas? And part of me is, if you were getting ready to study for a test, is this something you could do or you would try to do to help you get ready? And what's really important? So if I start thinking back through chapter 4, I want to know what, what is in my trig inventory right now? What are the things that we've done? And I'm just going to start writing them down. And hopefully you can use terminology to go along with it. But I'm just going to start writing stuff down. What have you learned recently that I can put on this sheet? Go.
Angular and linear speed.
Okay. Angular speed. What letter was it?
Or not W. Great question.
Anybody jump in? There are angels among us that'll help us out.
S.
All I heard was X. Sorry. Whoops. That's not how he spells. What was the formula for angular speed?
E.
S.
W equals.
Oh, for angular. W or wait, theta over T.
Theta over T. And again, it was the change in the angle with the change in time. Okay, that was my angular speed as the angle changed over time. Okay, linear speed was pretty close to that. That was the V. And yeah, Kelsey, arc length, I'll put that next. And this is one thing that some people do. They do a memory dump when they're taking a test. And the first thing they'll do is just take a piece of paper on the side and write all this down so that they have it and they're consistent through the test. If this was the change in angle over time, this is the change in, wasn't it S, the arc length over time? Because that was a line. We had a formula for arc length. S equaled.
That theta R.
Theta R, yeah. And we did some other things in here where we manipulated some of these by using some of the other ones. And one of it was, instead of S here, I said V equals theta R over T, but I knew theta over T gave me V equals, in place of the theta T, I'm going to put W R. So I'm just doing a memory dump to get ready for the test. That was some recent stuff that we just did. Oh, we also added something in here. One of the things we mentioned, one revolution, because that's a term that comes up once in a while. One revolution equaled
2 pi.
Yeah, 2 pi. And again, when the label's not there, it's radians, but we can put it in as well. So that's some recent stuff that we had. And, we manipulate these all over the place. For example, one of the things I could do is say, oh, well, theta equals WT, S equals VT, S equals theta R. So somewhere along the line, you were given things like Q equals R plus 1 over 2, and you were asked to solve for R. And you multiplied by 2 and subtracted 1, but we rearranged equations for different things. Well, that's now where this is coming into play. How can I rearrange so that theta equals WT kind of deal? What else did you have in your inventory? We had
Learned about like graphing and whatnot.
Yeah, we had graphing. So what is it to remember about? What was give me a generic formula to help me out with all of my graphing. Y equals.
A times the function
Yeah,
of
let's go with sine. Okay, good.
B
Yeah,
times X minus H
yeah,
plus K.
plus K. And when we graphed, we did H back. We found the H, the B, the A, and the K. And we didn't have to graph. The defaults were H is 0, B is 1, A is 1, K is 0. But if those were something else, then I had to use that as part of my graph. But if I say, here's an equation, give me H, B, A, and K, you need to come up with those. And the tricky one was pulling the B out. Okay, so yeah, good part of memory dump. That was just scribble over there.
I got a question about those on the test.
Yep.
So I'm assuming in D2L, we can't really graph stuff.
Nope.
Are most of the questions going to be, yeah, just looking for HBAK?
Yep.
All right, neato.
Yep. And then there may be discussion, but you're getting a lot of homework problems with looking at the shifting up and down. This was a classroom test, most definitely. I'd have the 4 graphs on there and make you graph all 4 or all 5 of them. How about on the assignment number 2 sheet? Was there any on there? I'm just doing a quick test to see who started working on it already. Because I do have one submitted, which is just awesome. One person's done. What else did we learn? Maybe back in chapter 3, we had a couple of things like, we had these things called identities. And when we first started learning about sine and cosine, and what were some of those? Can you, at this point, say, oh, yes, I knew I got that, I got that, I got that. I'm writing down everything he's writing down before he's writing it down, which means, hot dang, you're in good shape for next Monday when we take the test. What were some of the identities? There were equal signs in them, like
there was one where sine theta or sine squared theta plus cosine where
Yeah.
theta equals tangent.
now it equaled, nice and simple. It equaled 1.
No.
Yeah, that was the Pythagorean identity. This was the Pythagorean, because this was the one where we used a unit circle and we said, well, yeah, cosine equals X over R and sine equals Y over R. But if R is 1, the radius is 1, sine, I could just do sine squared plus cosine squared equals 1. And then I did some more. There were 2 more that came out of this. This is the one I had to remember, and it's great. I love it. Okay, but there were 2 more. One was, what if I divided everything by sine squared? That makes this a 1. This becomes cosine over sine, which is cotangent. And this becomes 1 over sine, which is cosecant squared. See, I only had to remember 1, and then the idea is I divided by sine. What if I divide each one of these by cosine? Sine over cosine is tangent squared. Cosine divided by cosine is 1. 1 over the cosine is the secant squared. Yeah, so I had 3 of those formulas. I'm like, yeah. So far, so good. I had this one. I knew that 1 over the sine of theta equals, I just used it over here,
Cosecant.
cosecant. I know 1 over the cosine is the other one.
Secant.
Yeah, the secant of theta. And then, of course, 1 over the tangent is cotangent. I even had this one. This one was the tangent of theta equals sine over cosine.
I have a question.
Yeah,
Yeah, so cosine square of theta can be equals to 1 minus sine square of theta.
absolutely. We can manipulate. remember we were talking about how we have these and where they came from. But once I have them, I'm going to manipulate them once in a while to get to what I want to get to. Same thing down here. You're going to see in chapter 5 something that has 1 minus the cosine of squared of theta in it. And you're going to go, wait, I can replace that with the sine squared of theta. Again, I just manipulated this identity. Identity, it has an equals in. One side is identical to the other. So yeah, I'm going to be doing things like swinging that over. You know, I'm going to subtract cosine squared from both sides. I'm going to, oh, that's ugly. Wait, that's cleaner and simpler. Great question. Okay, so I just did a memory dump. This would be like me saying, okay, you can have, and you can't. So I'm just clarifying here. You can have 1/2 a sheet of a 3x5 card on one side only that you can write all the formulas down. Everybody's cramming these little formulas and they're writing them and they're writing them and they're using them over and over. And then the test comes around. I said, now you can't use them. And you're going, oh man, well, I did it enough times that I can remember a lot of these things that we've done up to this point. Okay. Good. Great start. Now, we're going to look at a video for 4.5 because I think the guy does a good job and it's nice to hear somebody else's voice and some other things, but we're going to keep this guy in mind up here, this angular speed. And one of the things about the angular speed is, I mentioned this a little bit as a foreshadowing. What does theta equal? Well, if I bring the t over, theta can be replaced by WT. So keep that in mind. So what I'm now going to do is, and I put something on D2L, you don't have to go there, but it's a video link to something for section 5.1 for us. And I'm going to stop the recording now. And instead of me teaching, I'm going to let this guy. Okay, did you like the videos? Yeah, we got a couple of thumbs up. I thought it was as good as I could. Well, one of the reasons I did that was I want you to be able to say, okay, I'm stuck. I'm going to go look at the video and maybe see what I can find on Google to help me out, you know, or YouTube. The Google doesn't forget. The Google has all of that on there. So if you're stuck, you can't get a hold of me, no classmates are responding, you can always jump on there. All right, so that's going to put an end to chapter 4. Are there any questions about chapter 4? And again, we were talking about he was using WT instead of theta so that he could do it in terms of time. And where did that come from? That came from angular speed. No more questions on chapter 4. And we are ready to start chapter 5. We're ready for the test on Monday. Test on Monday. Yes, test on Monday. Okay. Excuse me. Section 5.1. We're going to be doing some neat stuff in chapter 5 that to me is like puzzles, but we're going to go back and we're going to talk about some of those fundamental identities that we've already looked at. And having just gone through those, if I said, what are the Pythagorean identities? With a little luck, you're going, oh yeah, we just talked about them, I'm good. That's the sine squared of theta plus cosine squared of theta equaled 1. And then we did the other ones where we did the division. And I got 1 plus cotangent squared of theta equals the cosecant squared of theta. And we had tangent squared of theta plus 1 equaled the secant squared of theta. Okay. That's good. Still remembering a lot of that. I'm happy. You know, we built our inventory on this last sheet with a bunch of different things. Down here, we had these identities. we had the reciprocal identities. You know, we had the tangent of theta equals that, the cotangent of theta would equal the reciprocal of this. So really, I could have added this on there, the cosine over the sine. Okay, so they're all of our identities up to this point. Something else that I want to bring up, we talked about the other day, was odd functions and even functions. Uh-oh, trains are coming. Now, if I wrote odd functions and even functions, and I'm doing this right now with my college algebra class, I'm hoping that you go, okay, I think I remember this. An odd, I'm going to simplify it, y equals x cubed, because that was odd. Y equaled x squared, because that was odd or even. And when I did the odd, if I graphed it, if I did the even and I graphed it, so far so good. Let's see, this was over the origin, meaning I rotated it 180 degrees, picked it up, right? This was over the y-axis. Happy with that. Okay, I'm still going. If I pick a number, plug it into this function. If I say 2, okay, I take a look at its opposite, -2. And I say, okay, I want to plug it into the function because remember, f is always this, or y is always the same as f of x. If I plug 2 in, what's 2 cubed?
8.
8.
8.
If I plug -2 into the function, what do I get out?
-8.
-8. So what do I know about these two answers? They are
Opposite.
opposites. So if I picked any x and plugged it in, 3, 9, 14, and I plugged in its negative, I know its negative is going to be opposite. So I'm going to put something like these two are equal if I multiply that by -1. So for every x, if I plug it into the function, take its opposite, plug it into the function, these values are opposite. Is that where that equation comes from? Yeah, buddy. Take a look at this one. If I put 3 and -3, I have an x and its opposite. What's 3 squared?
9.
9. That's 9. What is f of -3? When I square that, I get 9.
9.
So if it's even, every x I pick, when I put it into the function, is going to have the same value as its opposite plugged into the function. Yeah, okay. What's your point? I learned all that in college algebra. Yes, you did. But we have trig ones. I know, I want to have more up here than what I do. Sine of x. Is it even or is it odd? The sine of x. The sine of x. I'm going to plug it. I'm going to look at the graph. I need to look at the graph. And if I kept going this way, what does that mean? What does that look like, even or odd? Can I flip it over the x-axis?
Even? No.
Positive.
No.
Negative.
Yeah, if I picked an x and went up, I picked a -x and went down, what do I know about their y values? They're opposite. So the sine, y equals the sine of x, which is this graph, is going to be in the odd category. So what does that tell me? I don't know. What that tells me is this. My function is sine, so that I get something like this. The sine of x equals the negative sine of -x. What's the relationship if it's odd? Their y values are opposite. So I just created an identity that, yeah, maybe I'll tuck that puppy away. Cosine. Looks like that. And if I kept going, yeah, no, 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 no. What do you think about that one? Odd or even? If I pick an X, if I pick a negative X, what do we know about their Y values?
It's positive.
Yeah, they're the same. They're going to be the same. Okay. And that was my definition of an even function. So Y equals the cosine of X is an even function. Real quick, there's Y equals the cosine of X, which tells me, yeah, no, 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 no. If I pick an X, the cosine of X, and if I pick the cosine of its opposite, if I did the cosine of pi and the cosine of negative pi, they would be the same. So there's another identity. Sine is odd. Cosine is even. This is even. This is odd. One more, the tangent. Where do you think the tangent's going to go? Well, I need to look at the graph, because now that I have these graphs, I'm a little more kick-ass. And the tangent graph went like that. And it had asymptotes in. Yeah, no, 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 no. Does anybody remember where this first right asymptote was? What value?
pi.5.
No,
Two.
pi over 2. This was negative pi over 2. My tangent period was
Pi.
pi. Yeah, it was different. It's a little bit different. All right, so if I look at this guy, if I pick an X, how about that one? And I pick its opposite. What do I know about when I plug them into the tangent? Their answers are going to be opposites, just like the sine. So down here, Y equals the tangent of X, which was this graph. So again, I have, if I looked at taking an X value, or theta would be more appropriate, and I took the opposite, negative theta, that these two are going to be opposites. Odds and evens. Sine and tangent are odd. Cosine is even. And again, when I drew their graphs, it really helped me figure it out. But I needed that college algebra understanding of basic functions and how we were taking a look at that. Capiche? That's good. Okay. Sine of negative 30 degrees. What does that equal? Give me, by using the identity we just talked about, what does that equal? Well, let's see. Sine was, this is going to equal the sine of theta. If it's even, it equaled that. And I'm okay with working with this. If it's odd, I needed to put a negative sign in there. What was the tangent? I don't remember. Or excuse me, what was the sine? The sine went like that. So it was odd. So this has to be a negative. That's how my odd functions work. Oh yeah, yep. For real, yep. You talking to yourself? Yep. What do you think about this? The cotangent of negative X equals, well, the cotangent's going to work just like the tangent. And the sine was odd and the tangent was odd. So this is going to equal negative the cotangent of X. Examples. Examples. Strangers in the night. All right. We have a bunch of identities, and I have this equation. I know this to be true. 1 plus tangent squared of theta does in fact equal the secant squared of theta. Now, what if I said we'd like to change this up a little bit and rewrite it and start to manipulate it, okay? Do something else to try to make this become true. What can we do with it? Well, we already know it's true, but I kind of like to change it up a little bit. And one of the things I can do to change it up is look at it in terms of sines and cosines. Okay, 1 is just 1. Tangent squared is like tangent times tangent. That's going to be tangent of theta times tangent of theta, which is sine over cosine, sine over cosine. So sine times, oh yeah, this becomes sine squared of theta over the cosine squared of theta. Got that. This equals 1 over the cosecant squared of theta. Got that. So I'm just learning how to manipulate these, how to turn them around, because next Wednesday when we're in 5.2, we're going to be doing something called verifying the identity. And we're going to be given not something that we already know, but something that we're going to have to manipulate and change so that we can prove it to be true. Okay, yeah. Oh, so here's one thing. If I take a look at this, my right side is a single term. Okay, the first thing I did, I changed it to sine and cosine. I feel much more comfortable working with sines and cosines. Second thing I'm going to do is say, well, if this side is one term, maybe I should make this side one term. And if I want to add two things together and one's a fraction, what do I have to do to the other? Okay, so when I used to teach AP Calc in high school, one of the things I would always say doing calculus things was, can I make it something familiar? So I just ask a question, and what if I had this? 1 plus 4/3 equals x thirds. And I want to, what would I do here to this left side?
Subtract it on both sides.
Well, no, I want to leave this side alone. Can't touch that. Hammer time. Oh, oh. See, I'm doing the hammer dance. You can't see it. Oh, oh, hammer time. I'd like to combine these. Okay. How do I combine them?
So you have to make the denominator equal to each other, and
Yeah, I need to make this a common denominator. So I would say, okay, I'm going to change this to 3/3 plus 4/3. And then I'm going to say, oh yeah, 7/3 equals x over 3, x equals 7. So going back to my basic algebra skills of wanting to combine these, I'm going to take that first term and rewrite it to a different version of 1. And that different version is going to have the same denominator as my other term. Okay, now that I have the same denominator, I'm going to make them a single term. This becomes cosine squared of theta plus sine squared of theta over the cosine squared of theta equals 1 over, well, if the left side and the right side both have the same denominator, and again, this is different than what's up here. I can't just say, oh, there's cosine squared, I can drop them, because this is 2 terms. I need to make it 1 term. I can now drop the cosine squareds. See you later, alligator. Oh yeah, I'm a little more familiar with this. This is my sine squared of theta plus cosine squared of theta equals 1. And I'm going, oh, whoop, whoop.
It's possible to flip it.
Flip it. What? Oh, so going back to algebra. Does 1 plus 2 equal 2 plus 1? The commutative property.
Okay.
Good catch. So again, this is chapter 5, not going to be on the test, but we're starting to get revved up for chapter 5. Because chapter 5 means we're kind of almost starting the second half of the year. We're happy about that. The second half of the year. I want to show you something real quick. Just a reminder. Here we are today with 4.5. Okay, 5.1. This is Monday is a test. Next Wednesday, we're going to be in 5.2. The week after, March 7th, that Monday, we're doing 5.354. That Wednesday, we're doing 5.5. Well, that we have 15 classes in at that point. Well, this date here isn't 3/14. This date here is 3/21. That's because at this point, we have spring break. So we're going to go into spring break with 15 classes down and 13 to go. But yeah, we have, right here, wow, we're on this Wednesday. Next week is the test in 5.2. The week after is 5.3 and 5.4 and 5.5. And the week after is spring break already. So I was out raking the grass. I'm going to put grass seed down. I want some of those areas to come in. So after today, it's 2 more weeks. Man, spring break. Bring on the Irish. We're all Irish, right? At that point. All right. Here we go. I have a problem here. I have 1 plus the cotangent squared of theta over 1 minus the cosecant squared of theta. What I want you to do is I'm going to put you in pairs and shares. I know some of you like it, some of you don't, but it has its benefits. I'm going to put you in pairs. I want you to do this to this problem. Rewrite in terms of sine of theta and cosine of theta and simplify. So I want you to rewrite this in terms of sines and cosines, and then I want you to simplify it as much as possible. When you have an answer, you come back and show me, and I'll say, cool, your pair has it. You're done for the day. You have a great weekend, and I will see you on Monday for the test. Make sure you get that assignment number 2 done. That's 30 points.